This next video discusses how to configure VLANs. In this video, we'll start with the basics and show how to configure VLANs on Cisco switches. Then we'll move on to some related topics. First, we'll talk about the VTP mode on switches, which impacts how VLANs may be propagated to other switches. Then we'll talk about how to verify the status of a VLAN trunk. So we'll talk about the verification first, and then we'll show how to configure those same trunks. And one last note, we borrowed this video and several others from the CCNA Video Mentor 2nd Edition product. You may hear or see a few references to things like the product itself or another lab number. You can just ignore those. Now onto the video is borrowed from the Video Mentor.
The scenario for this video has two major parts. In the first part, we'll see the three-step process by which you can create your first VLAN on a switch. The steps are that you first configure VTP mode, then you create the VLAN, and then you add interfaces to that VLAN. Following that, the second part shows how to configure 802.1q trunking between two switches. Scenario Step 1 has three main sections. In this first part, Switch 1 is going to put those two PCs into VLAN 11. Now this is the first VLAN created on Switch 1, so we'll use the following three-step process. First, Switch 1 needs to be configured with the VTP transparent mode. Switches default to server mode, and for this lab we're going to use transparent mode. That'll prevent Switch 1 from telling Switch 2 about this new VLAN, so we can then go configure Switch 2 to add a VLAN as well. The second step will actually create the VLAN, and at the third step we'll put the interfaces FA011 and 0/13 into VLAN 11. Now once you go to create a second VLAN, notice that you'll only have to do steps 2 and 3 again. You only have to configure the VTP transparent mode once. Next, step 1 shows the same process on switch 2, except we'll use a shortcut. On switch 2 we'll configure the VTP mode to be transparent as well, but instead of first creating the VLAN 11, we're going to just put the interface there, FA0/12, into VLAN 11. Then switch 2 will automatically create VLAN 11. Also note that switch 1 and switch 2 will use an 802.1q trunk between themselves. The second part of this video lab covers how to configure 802.1q trunking. To see how to configure VLANs, we'll start at the command line interface of switch 1. However, first let's do a show command, show VLAN, and take a look at the existing VLANs. Although no VLANs have been configured yet, you see VLAN 1 is there. Every Cisco switch has VLAN 1 configured automatically and you can't delete it. There's also VLANs 1002 through 1005. Those VLANs are typically not used today and are still shown in the show command for historical reasons. Next, we'll get into configuration mode, and then we'll configure the VTP mode to transparent mode. We'll do that using the VTP mode transparent command that you see there. Press the enter key, and there you go, you've set the VTP mode. It's that simple. Then to create VLAN 11, we need to use the VLAN 11 command. We type that command, and then press enter. Note the command prompt changes, and you've also created VLAN 11. Now you don't have to configure anything else about the VLAN, but if you'd like to give it a name or assign a name to the VLAN so it's more meaningful to you, you can do so. In this case I'll use the name space this is VLAN 11 command to assign a name to the VLAN. So that's the first two steps, setting the transparent mode and then creating the VLAN. At that point you just need to assign each interface to that VLAN that you want to be in that VLAN. In our case we want to put interface FA011 into that VLAN, so we'll type the interface FA0/11 command, that's shorthand for fast Ethernet. Press enter. Notice we're in interface configuration mode now, and then you just type the switch port access VLAN 11 command and press enter. At that point you've placed FA011 into VLAN 11. Now you want FA013 in that VLAN as well, so if you switch over to FA0/13, now you're in FA013 interface config mode, and just repeat the switch port access VLAN 11 command, and now you put both interfaces into VLAN 11. Next, by getting out of config mode, we can do the show VLAN command again. As you'd expect, now the output shows VLAN 11 as you see there. We see the name of VLAN 11 of this is VLAN 11. And out to the right, you see the fact that FA0/11 and 0/13 are now interfaces in VLAN 11. Next, on switch 2, we'll configure VLAN 11, but use a little bit different process. We'll get into config mode here on switch 2, and then use the VTP mode transparent command, as you see there, to set the VTP mode. Now, instead of adding VLAN 11 explicitly, we're going to get into Interface, Fast Ethernet, 0/12, which is the port connected up to PC2, and put that interface into VLAN 11. Now, switch 2 does not have a VLAN 11 yet, so as you see in the message generated there, the switch noticed, oh, you want to put this interface in VLAN 11, I don't have one, so I'll automatically create one. So if you get out of configuration mode and do the show VLAN command here on switch 2, notice there is indeed a VLAN 11. It was automatically created, and since it was automatically created, the switch made up a name, in this case VLAN 11, for that particular VLAN. The two switches have also dynamically agreed to use trunking on the link between the two switches. As a result, traffic for VLAN 11 can pass between the two switches. In fact, not shown on the screen, the three PCs have all pinged each other at this point. Now we can verify some of that from the switches by using the show MAC address table dynamic command, as you see here, and add the VLAN 11 parameter. By doing so, we just see the dynamically learned entries inside VLAN 11. Notice there we see the three MAC addresses of the mostly 1s, mostly 2s, and mostly 3 MAC addresses of PC 1, 2, and 3, and notice they're dynamically learned on the correct ports. Next, the second part of this video lab shows how to configure trunking on two iOS-based switches. The key to the configuration is the switch port mode interface subcommand, and this command has one of several options that are listed here in this table. For instance, if you code the access keyword on the switch port mode command, it tells the switch that for that interface simply do not trunk. Treat the interface as an access or non-trunking interface. If you configure the trunk keyword, it tells the switch to always trunk. Many network engineers go ahead and configure switch port mode trunk on each interface that they know they want to have trunking. The next option on the switch port mode command that you see here is the dynamic desirable option. This option tells the switch to initiate the negotiation of whether trunking is possible, and if the neighboring switch is willing to trunk, to go ahead and indeed trunk. Now, if you compare that to the fourth option, Dynamic Auto, it works the same way, except with Dynamic Auto, the switch does not initiate the negotiation process. Now, it brings up an interesting issue. If you have two switches configured for Dynamic Auto, neither one of them will initiate the negotiation process, so trunking will not occur. As it turns out, the 2950 switches used in this particular lab both default to use Dynamic Desirable, so they initiate the negotiation process. However, at the time this video was recorded, 2960 switches default to Dynamic Auto, meaning they will not dynamically form a trunk with default settings. So let's begin by taking a look at trunking on switch 1. If you use the show interface trunk command, as you see here, you get to see information about each trunk on a switch. In this case, switch 1 only has FA 0/23 as a trunk. Notice there's the interface, and it lists a mode of desirable. That's a reference to the configured trunking mode, and since switch 1 is defaulted to use dynamic desirable, this command output lists desirable. The status over here on the right is trunking, which means that switch 1 has indeed negotiated the use of 802.1q trunking. And I know it's 802.1q, first of all, because I know this is a 2950 switch and it only supports 802.1q. But over here in the middle of the output, we see the encapsulation type listed as 802.1q. Next, you'll see how to configure the trunking mode. What we'll do here is configure switch 1 to statically use trunking and let switch 2 still dynamically negotiate to use trunking. So if we get into configuration mode with the configuration terminal command, then we want to get under interface fast Ethernet 0/23 as you see here. Now once you're in interface configuration mode, all you need to do is configure the switch port mode command, and in this case we'll use the trunk option, which statically configures trunking on that interface. Now if we get out of configuration mode, we can go back and see the differences in the show interface trunk command. So here's a show interface trunk, and notice now that the mode, instead of saying desirable, says on. Once again, it's a reference to the configured trunking mode, and this is to say trunking is configured to always be on. We're still using 802.1q, and the status is still trunking, meaning that we're still using trunking between the two switches. As it turns out, with switch 2 in dynamic desirable mode, switch 2 starts to negotiate trunking, notices that switch 1 is already using trunking, so switch 2 says, okay, the other guy wants to trunk, so I will too. This concludes ICND2 Lab 1. In this lab, you've seen how to configure VLANs on Cisco switches, how to configure the VTP mode, how to determine the current status of any VLAN trunks, and how to configure 802.1q trunking between two Cisco switches.